Hey guys, good morning. Welcome to the Aerospace Structures lecture series. So, in continue of the fatigue strength and analysis, today we are going to see the fatigue life regime and fatigue design. So, here we are going to discuss about a few topics like fatigue life, calculation of fatigue life regime, characteristics of fatigue life regime, and fatigue design. So, in fatigue life is a number of stress cycles that a specimen sustained before it fails. It has two characteristic periods like crack initiate and propagates. It depends on loading and shape of the materials. An SN diagram is a graph of the magnitude of the cyclic stress against the logarithmic scale of cycle of to failure, that is n, which is shown in the figure. That is a SN diagram. Stress versus number of operating cycle. Stress is the magnitude of the normal stress and the cycle to failure. SN diagram depends on applied loads on the life regime, low cycle fatigue cycle and high cycle fatigue cycle. So these are two types of the fatigue life. The classification of fatigue life regime, one is low cycle fatigue, that's a LCF, high cycle fatigue, that's a HCF. The classification criteria, the number of operating cycle is 10 to the power of 4 and below. We call this a low cycle fatigue cycle. In some cases, the number of operating cycle is 10 to the power of 5 and above is called as a high cycle region. Practical classification, N is less than 10 to the power of 3 is a low cycle region, N is greater than 4 is a high cycle fatigue region, 3 to 4 is intermittent life region, and 9 to 10 power of 10 is very high life cycle region. It is shown in the graph: low cycle fatigue region, high cycle fatigue region, intermediate fatigue region, and ultra long life region. These are the various fatigue life region. So the main thing we are going to concentrate is low cycle fatigue region and high cycle fatigue region. The characteristics of fatigue life region: low cycle fatigue, that is a fatigue due to the plastic. When the stress is high enough to generate plastic deformation, the stress is of no concern, but the strain describe the failure better. In the low cycle fatigue test, it is deals ideal to control the amplitude of the plastic region. Particularly, a total strain can be controlled because of it is easier. Because of the large plastic strain, the fracture happens very fast, thus the life is highly depends on the crack propagation period. Second one is eye cycle fatigue. The most region experience the elastic strain and the region of plastic strain is very small. The life depends on the crack initiation. Fatigue limit. If the stress is less than the fatigue limit, the fatigue fracture cannot occur. The fatigue limit is decided as a stress level having 10 to the power of 7 cycles in a case of steel-like material. Because of long life and environmental effect is important. The life is affected by the uncertainty of the metal uniformity. Thus, the statistically approach is the necessary. In indeterminate life region, both crack initiate and propagates take place are very important in the cycle region. Many cases, the interpretation of from the results of high cycle and low cycles are in the use. Fatigue design. The concept of fatigue design makes two component in the infinity life design operate in the safe life design. Even though it get fails, it should operate. That's a fail life design. Even though it gets some damage, it should tolerate in operation. That is a damage tolerant design. These are the four concepts of the fatigue designs. Infinite life design, a good design or a design method based on the fatigue limit. It is a traditional and simple method. It has a problem of an over design. It is widely used for products that require highly reliability and safety. Coming to the safe-line design, turbine of the power plant, wings of airplane need to be safe-line design. Calculation for cyclic maximum stresses. Design and the strength of the product that should ensure a design life for a given load cycle, even though crack initiate is more considered. This is one example of commercial airplanes applied safe flight design concept. Fatigue design, fail-safe design is another thing. A method that a structure is designed not to fail before the detected failure is repeatedly repaired. This method comes from the fatigue design of the airplane. A method having multiple loads path, intentionally weak lines, a method having many redundant, that is the having method to make crack stop or crack arrested, early detection. Periodic examination is required to detect initial fracture or failure or the fatigue. Coming to the damage tolerant design, this method assumes that a crack pre-existing in the structure. A structure is designed not to fail in a periodic maintenance period. Although the structure has to initial crack, consideration need to be done in the initial crack length, crack propagation speed, maintenance period, fracture toughness. These are the be considered during the damage tolerant design. A metal having low crack growth rate and high fracture toughness is the proper need to be done. In the crash test, a few examples are shown in the figure. So these are the things that we need to be concentrate on the fatigue design, fatigue design um materials or the structure in the aircraft or other materials, other structures. Thank you guys. We'll see you in the next test. Thank you.